So let's talk a little bit about scope. What does scope mean? Scope is sort of like jurisdiction. If you have an expression like this basic form, we have the slot on the left, slot on the right, connected together by a material equivalence sign, then the jurisdiction, as it were, of this operator, material equivalence, is going to be whatever is in the square on the left and whatever expression is in the square on the right. So why do we think of it like that? Well, remember, all of our operators are truth functional operators. In other words, they're basically like functions. And so what this operator operates on, essentially, is the truth value of whatever is in the square and the truth value of whatever is in the triangle. And it takes these two truth values and uses them as inputs to a function, and then the inputs are mapped onto a specific output. And we saw that with the truth table for the operator material equivalence. If we construct the truth table, what we find is we have, for each row of the truth table, we have two truth values going in, one for the left expression, one for the right expression, and one truth value coming out. All right, so now one last thing for this. I know this is getting a little bit long, but I want to do one last demonstration here. Suppose we have an expression that's even more complex. Like let's have P implies Q or S grouped together, implies, and then let's have P or Q, and it's not the case that S. All right, grouped together. All right, now, question, what is the operator of largest scope? Well, you have several to choose from. You have a material implication here, you have or here, you have material implication here, another or, an and a negation sign. So what we want to do is look at the scope, in other words, the jurisdiction. We want to look at the scope for each one of these different operators and ask which is the operator of largest scope. So if we do that, what we're going to see is that each one of these operators has a slot, either a slot on the left and a slot on the right for binary operators, or in the case of this negation sign, it has only a slot on the right. And so what we're going to do is we're going to look at the jurisdiction of all of these operators and ask which operator has the largest jurisdiction, as it were. So at this point, it's probably obvious that the operator with the largest jurisdiction is this central operator, the material equivalence. Why is that? Because on the left-hand side, all of this belongs in the square, and on the right-hand side, all of this expression belongs in the triangle. If we break these down, let's just do that on this side. If we break this down, what we see is while this is the operator of largest scope, what we have is we split into this P or Q and not S. We can treat this expression sort of like fresh, right? Because we know it's a component part of this material implication. So in this expression, what is the operator of largest scope? So you have three choices. It's either this or, this and, or this negation sign, right? So let's look at the slots for these. This and has all of this on one side and all of this on the other side. Sorry, once again, I've changed types of triangles. And so if you look at this scope, the scope of this and operator, the jurisdiction, is bigger than either the scope of this or the scope of this negation sign. So let's take this negation sign as an example. The negation sign operates only on S, so its scope is pretty small. This or operates on P on the left-hand side and Q on the right-hand side. So it turns out that in this expression, this and is the operator of largest scope. And this and joins together two different expressions. On one side, the expression is P or Q, and on the other side, the expression is not S. So notice what we've done is when we've branched down like this, we have dropped this triangle piece down here to this branch, and this square piece has dropped down to this branch. Why does it have two branches? Because the AND operator joins together two different things, one thing on the left hand side and one thing on the right hand side. Okay, does that make sense? I hope so.